Hi everyone, welcome back to TemRTube. Today I'm going to walk you through a powerful workflow. How to model tunnel blocks in Rhino, control them parametrically in Grasshopper, and then transfer them directly into Revit using Rhino Inside. This workflow gives you full flexibility. You can design in Rhino, manage parameters in Grasshopper, and update your Revit model anytime. Before jumping into Rhino, let's take a quick look at the Revit family we'll be using. I created a new work plane-based generic model family called Tunnel. Let's open it. As you can see, the tunnel block is simply a cylindrical ring with parameters of inside radius, a thickness, and the outside radius, which is computed from the inside radius plus thickness. We also have a block length. Under family types, you'll see the three parameters I defined: inside radius, outside radius, and block length. I set all of them as instance parameters, so Grasshopper can modify them later. That's all we need from Revit for now. Now let's switch to Rhino. I've already installed Rhino inside Revit, so I can launch Grasshopper directly from Rhino. Let me open the Grasshopper script. Inside Grasshopper, the first thing I did was create two circles. One for the inside radius, one for the outside radius, which is simply inside radius plus thickness. Let me change the thickness so you can see how the outside radius updates automatically. This gives us a fully parametric tunnel section. From these circles, I created boundary surfaces and then used split to subtract the inner surface from the outer one. Now we have the ring-shaped tunnel cross-section. I moved it slightly to the right just for better visibility. Next, I defined the tunnel axis. In Rhino, I placed 3 points. Grasshopper uses these points to create a curve. This curve represents the tunnel centerline. I divided the curve into 10-meter segments because I want each tunnel block to be 10 meters long. From each division point, I extracted the tangent vector. And from the tangent, I created perpendicular planes. You can also use the curve perp frames component, but I built it manually here. These planes will be used to orient each tunnel block along the axis. After orienting the tunnel cross-section onto each perpendicular plane, I moved the sections into position and extruded them. The extrusion length is 9.95 meters. I intentionally left a 5-centimeter gap between blocks. This gives us a fully parametric tunnel composed of multiple blocks. Now let's transfer everything to Revit. Inside Grasshopper, under the Rhino Inside Revit components, I used Add Component in Work Plane. Because our Revit family is work plane based, we need to provide the work plane, the family type, and the location. For the type, I selected generic models, the tunnel, the family we created earlier. For the work plane, I rotated the perpendicular planes so they align with Revit's XC plane. These planes are fed into the component as the placement planes. Once I run the component, Revit generates the tunnel blocks at the correct positions. If I zoom out in Revit, you can see all the blocks placed along the tunnel axis. Now comes the powerful part. I used the element parameters component to modify the Revit instance parameters. I connected the output of the add component node to the element parameters node. Inside the parameters list, I added inside radius, outside radius, and block length. For the outside radius, I used the Grasshopper thickness value. For the block length, I used 9.95 meters. Let me show you how it updates. If I change the inside radius in Grasshopper, Revit recalculates the family and updates the geometry. It takes a moment, but you can see the block getting larger. Inside radius is now 16 meters, outside radius 17 meters, exactly matching the Rhino model. You can also change the parameters directly inside Revit, and Grasshopper will still maintain the relationship. This workflow has huge potential. You can store your inputs in Excel or a database, generate tunnel blocks or similar repetitive geometries parametrically, control their position and orientation in Rhino, and update your Revit model anytime with one click. It's flexible, fast, and ideal for infrastructure projects. If you found this tutorial helpful, don't forget to like, share, and subscribe to TemRTube. Your support helps us create more content like this. Thanks for watching, and see you in the next video.